All right. Oh, we're live. Look at that. See, it even surprised me that time. I was waiting, and half of my shows start with, "Are we live? Are we live? Oh, we're live. There we go." So, hey, welcome to Sessions with Sam and Friends. I'm super excited to be here with Elad and Shai. And I really appreciate y'all coming on. Thank you. I'm going to have y'all tell us who you are and why are you here. I mean, I'll obviously talk about it in a minute too, but tell us who you are.
Shai, do you want to kick it off?
Elad, why don't you go first?
Okay.
Cool.
So I'm Elad. I'm here because we've known each other for I don't know how long, maybe 5-6 years already.
I have a story for that when you're done.
Okay. But yeah, we're building this new thing called Wing, which is a programming language for the cloud. In a sense, it's kind of like an evolution and the next step of the previous project I worked on, which is the CDK at AWS.
I worked on,
which was an amazing adventure, and it's really awesome to see you all talk about it here in the show. And I feel like a proud father sometimes when I see people show off the CDK and what it can do. And so Shai and I kind of joined forces about a year ago, almost to date, after I left Amazon, and decided that we want to solve the cloud development experience problem. We felt, we both worked at Microsoft together, and we're friends, and we both built stuff on the cloud, and have spent some time at AWS. And we felt that developers don't have the right tools to build applications for the cloud, to build services for the cloud. And we realized that the most important tool for developers is their programming language. It's the thing that they use to express their applications. And we started thinking, are the programming languages that we use today for the cloud, are they designed well to support this new programming paradigm, this new type of computer, in a sense? And if you take a little step back and you're thinking about it, you're like, well, actually, as far as these programming languages are concerned, and these compilers are concerned, their mental model of the computer is a machine, right? There's memory, there's CPU, there's disk, there's processes. But this is the mental model of the compiler. That's the abstraction that developers get when they use all of the programming languages that we use to build applications today for the cloud. And the reality of the cloud is that it's not a machine, right? It's a distributed system. It has all these services. Right. And so there's this impedance mismatch between the languages that we use to describe what these applications need to do and the applications themselves. And what happens is that we end up with these compilers that see only part of the picture every time, right? Like I have a compiler that can see my Lambda function, or this Lambda function and this Lambda function and this container, or the infrastructure, but there's no compiler that sees the entire picture. And coming from a developer background, from a programming background, the whole point of the compiler is to protect you, right? Is to give you to couple things together, right? Like when I call a function, the compiler will tell me if I pass in the wrong number of arguments. And that doesn't happen in the cloud. If I call a Lambda function or its service in the cloud, the compiler won't tell me, hey, this service actually doesn't take these amounts of parameters. And so now I need to start piling up layers and layers of tools and frameworks and protections in order to make sure that I actually am able to call the service, right? And so forth and so on. And so the reality was that the result was that we were saying, hey, what would it take to build a new language? It's a scary thing to do, going and building a new language. Yeah. And
just to shock you, I've never written a new language. Just throwing that out there. I've never created a language ever. So sorry to interrupt.
Well, you just told us that you learned Hebrew, so I think it's.
Well, no. I told you I took Hebrew.
Oh, you took Hebrew.
There's a vast difference. I took a year and a half. I squeezed 2 semesters into 3, because I failed the second semester. and for the audience, when we were before we started, I had stepped away, but I could still hear them talking, and they switched to Hebrew because they're probably talking about me. And not one word, couldn't understand a single word they said. So yeah. So real quick, I'm actually Shai. Tell us who you are, where you came from, real quick, and then Elad, I want to go back to your conversation. It's really interesting.
Sure. So I'm Shai. Just met Eric recently, and I know Elad for 16 years now. We both met at Microsoft. We were software engineer there together for almost 5 years, and then we each went their separate way. But we kept in touch and had a startup, and Elad was one of the main advisors in that startup. And even before that, we joined forces in an open source project. Another open source project, and then we kind of met again, like almost a year ago. I heard that he left AWS and was starting something new and very interesting. We had joined friends that have said that this thing is amazing and huge, and I wanted to invest actually, and then we met, and turns out that it is really huge and amazing, and I never would have thought that I was going to build a programming language, but here I am. And actually, it's even more than just a language, because Elad mentioned the developer experience of developing for the cloud, and so it starts with the main tool, which is the language, but then you need more than just the language. You need to get instant feedback on what you're building, and you want to be able to have very fast iterations. So we actually took it even further than just a language. So now we also have a local simulator to develop for, and a console to manage that and be able to debug and to visualize the application. And we're going to see everything in a while.
Nice. Yeah. And I'm not going to talk for very long. People are here like Eric. We can see you talk anytime because I'm everywhere talking, right? But but we obviously want to get to the demo. But I want to, I love what you were talking about the DX, doing DX. And I wouldn't say this is so much of, well, we can probably split hairs and stuff like that, but it's almost more of a distributed computing, thing rather than just cloud. It's this idea because cloud, but obviously distribute cloud is inherently distributed in a lot of ways, unless you're just hitting these two instances. So it's this idea of distributed computing, and how do we maintain this debugging and this like you were saying, this compiler against whatever components we're dropping in that make up our backend computer. And that's hard. I mean, the bottom line is, it's just hard. And so I know that, we talked about last week, Amped was showing theirs. You guys have a different approach, but the same space, same idea of, we think, we want to help with DX. And so super excited about this.
Yeah. Sometimes we like to think about it as, you're building a distributed system, but that doesn't mean that you need a monolithic code base. Right. Sorry, that doesn't mean that you need a distributed code base. And
I follow what you're saying. Yeah.
And what happened with the cloud, or with the reality of the cloud today, is because you're building a distributed system, then the fact that it's distributed is leaking out to your developer experience, right? Because you need different tools for different parts of your distributed system. You need different tools for defining your infrastructure. You need different tools for compiling your Lambda functions. You need different, and you end up with this very disparate code base that manages this single system. And so what in a sense, what Wing is trying to do is it tries to separate these two concerns and say, we give you the experience of building a monolith, but when you deploy it, you're deploying it to a distributed system. And being able to actually give the developer the experience of building, because this is, as a developer, this is what I want, right? Like, I really do want to build a monolith, right? From the reasons of the developer experience. So I go on my compiler to see the entire picture and make sure that I didn't break anything, and be able to test everything locally and run locally.
But we want the advantage of, I didn't mean to talk over you.
No, go ahead.
I guess I did.
We're Israeli.
Well, I was going to go back to the story of the first time we ever met is when I hosted CDK Day, I think. And I remember doing the show with Elad, and I remember you looking at me like, man, you're loud.
Did I say that?
And you talk a lot, but yeah, we became buddies, and so yeah, that was a lot of fun. So, all right, well, I'm ready to bring your screen on. You ready? You ready for me to show it? Nothing. You don't have your bank account up or anything, right?
That's what we do best, I guess.
Okay, yeah, let's do it. Let's get to it.
Yeah, so we're gonna do very like Wing 101. Please, we've been kind of in this kind of echo chamber for Wing for a while. And so please stop us if something doesn't make sense or if something kind of doesn't click, because it's a great opportunity for us to be able to explain better what we're doing and why we're doing it.
If you have questions, post them to the chat channel. I'll be fielding those and asking if I have questions. And it's something Elad already. I'll just interrupt you right there. And other thing is, if you're watching, tell us where you're watching from. We like to see where you're coming from. We have people all over the world. So throw in a hello and where you are, and Elad, let's see some Wing.
Yeah. The other thing that I wanted to say is that Wing is an alpha. And what does that mean? So first of all, it's an open source project, and anyone can use it and shape it and join the community and be part of building this. But it's important to mention that it's not finished. I wouldn't use it for production at this point, and I would probably won't even be able to build real stuff with it yet. We are working on building our beta version, and that means that for us, it means that it's ready for people to be able to actually build stuff with it. So we're at the stage in the game where things are pretty shaky. You'll see some panics, you'll see some bugs, you'll see some problems. It's all part of doing open source, and that I believe in it, and I feel like that's how you need to build software.
Yeah.
But part of it is that it's not a finished product yet. So big disclaimer, right? So let's start with hello. The hello world of the cloud is a little cloud function, Lambda function, or Azure function, or GCP function, some serverless compute piece of compute that prints hello world, right? And so I'm going to start by bringing the cloud into my code. Bring is the import statement for Wing. And if I do this, I can see that I have a bunch of APIs. And one of them is function. So now I'm going to create a cloud function. And the reason this is a cloud function and not a Lambda function is because Wing has a standard library like every other programming language. And one of the goals of the standard library of every programming language is to abstract the platform that you're using, right? If I write a file in Java or in Node.js or in C#, I don't care if I'm writing a file, if I'm in a Mac or on a Linux system or a Windows system, or which file system I'm using below. I have an abstraction layer that abstracts the platform that I'm using. And so what we're doing with Wing, which is one of the most interesting and controversial aspects of the project, is we're creating an abstraction layer for the cloud. We're actually defining what are the basic building blocks of a cloud application, which is very similar. Go back to this analogy of traditional programming languages, where it took some time for us to understand as industry what are the primitives of a computer, of a traditional computer.
Right.
So I believe we've reached a point in the cloud, the evolution of the cloud as a technology, as a paradigm, where we're able to define this abstraction, because we can look across and it's like, well, this is the foundation, this is the basic layer. And that doesn't mean that you have to use only the basic layer or that you're constrained to using only that basic layer. One of the amazing things about Wing, and I don't think that we'll be able to show it right now, is that we're compiling to Terraform and JavaScript, which is something that I will show.
Okay.
And that means that you can interoperate with the entire JavaScript and the entire Terraform ecosystem. And so every resource, every provider of the Terraform ecosystem is a first-class resource in Wing. And similarly, every NPM module is usable from the Wing, from your Wing application. And so in a sense, that's kind of like one of the shortcuts we took when we decided we're building a language. We say we're actually leaning on we're building it on the shoulders of amazing technologies, like amazing ecosystems, like the JavaScript ecosystem and the Terraform ecosystem. And so I feel like that's an interest. So again, going back to this abstraction of the cloud, if you want to use a specific AWS resource in your application, you can use it. You're not constrained to using the standard library, which is the same as in traditional programming language. Like I'm not constrained to use just the file abstraction of the standard library. Okay. This has been a very long hello world, right? Okay, so now I've created this hello world thing, and I need to use it. I need to run it somehow, right? And obviously, if that would have been a serverless application, a SAM application, or a CDK application, I would go and deploy it to a cloud provider and go to the console and find my Lambda function and run the Lambda function and look at the logs and be happy. But because we're creating this abstraction, and one of the things that we can do is we can actually provide local simulation for all of those standard resources. And not only we can provide local simulation, we also created this tool called Wing Console, which allows you to interact with your Wing application when you're developing it. So we're going to start this application called Wing. We're going to use this command called Wing It.
Tell us where the name of that came from.
You tell us.
Well, from my understanding, you tell me if I'm wrong, that was a Corey Quinn suggestion, was it not?
Exactly. He's
yeah.
I was talking to him and I was like, hey, hop onto our Slack, it could be cool. And so he hops to our Slack, spits out this idea and goes away. And Mike drops.
It's drive by. Yeah, that's a Corey Quinn way. Yeah. But I like it. It was a good call out. So I don't agree on everything, but
I think it took like less than 2 hours before someone from the community picked it up and implemented it. So it's
yeah. That's great.
So as you see, I have this thing that popped up, which is the Wing console, and we're still designing it and building the UI and dark mode and all of that stuff. But what you can see here is basically you see the structure of my application, and it's not super interesting. It basically has just one function, and I can invoke my one function, and I get hello world, which is great. And I can also compile this to AWS. So I can do Wing compile target, and I can specify Terraform AWS, and I can just run this thing. And if I look at the target here, I see this Terraform directory with a JSON Terraform version of the Terraform in JSON, and I see all the stuff that I need, like an IAM role and IAM policies and Lambda functions and the S3 bucket for the assets. And I see the assets here that includes my archive, so it's bundling my Lambda function with all the dependencies. And so this is applicable. This can be deployed to AWS right now, and I can use it and do the thing that I told you earlier. I'm not going to do it because it's going to take too long. Hence, why we're building Wing.
Sure.
Okay, so now let's say I want to write a file to a bucket. Okay, put a file in the bucket. So I'm going to create a bucket here, and you'll notice that I have this thing called in-flight here, which is one of Wing's unique characteristics as a language is this concept of multi-phase programming. And the idea is basically that the program runs through multiple phases of execution. The first phase is the compilation phase, is the time when I'm compiling my code. There's actually code, my code is actually running during that phase. And if you think about it in CDK terms, it's basically synthesizing. So we've basically baked the synthesis, the CDK synthesis phase into the compiler. And so when I run my compiler, when I do Wing compile, it runs synth as part of that. After it's doing all the compilation, it basically synthesizes my code, which is why I've seen this Terraform thing outputted here. We're building, this specific target is built on top of CDK for Terraform. And we actually have a PR by community PR coming for support for AWS CDK. So you'd be able to basically say Wing compile -t AWS CDK, and you'll get a CDK directory. And so everything that's outside of this in-flight is what we call pre-flight scope. It's basically the time that defines the structure of my system. It's the infrastructure phase. Okay. And then everything that runs inside the in-flight scopes are the runtime stuff. It's basically the code that runs inside my Lambda function or inside my container. And so now it becomes interesting, because what happens if I do B dot here, right? I'm basically saying I'm interacting with this bucket that I've defined in my infrastructure. And you can see that I have what we call the in-flight API of this resource. And that's basically the data plane, right? It's basically my ability to interact with this resource from within a Lambda function, for example. And it's very minimal at this point. You know, we're still building it, and
Sure.
contributions are welcome, etc. But I can start doing things. So I can actually create a file.txt file called hello and Eric. Now this exclamation point is going to blow up everything up. Now, as soon as I saved it, it reloaded automatically into my console.
Okay.
And by the way, go ahead.
I'm going to throw out. So I started using your console like when you first put it. I've been playing with this. This isn't just for those watching. I've been playing with this because I love this idea. I think it's super cool. But this is a big improvement too. I mean, I liked when you first had your console out, but this is really slick. I like this. And I have a couple other questions, and hit me with your questions in the chat. But I'll let you go for a minute. But I do have some questions.
Okay. I think there's a stopping point.
Okay.
Right now. Okay, so now you can ask.
Wow. All right. So that's a simulation basically of an S3 bucket.
Of a bucket. Of a cloud bucket.
Okay, of a cloud bucket. Okay. But I'm going to talk AWS because I work for AWS.
Yeah.
So, but
the reason I'm saying that is because it's important to mention that we're not attempting to simulate S3. We've defined a contract that says this is an object store, this is a bucket, and it has a bunch of methods. They're not coincidentally, but they look like they're very familiar to people who are using S3, because obviously S3 buckets are object stores, and so
sure
we've learned from the best. But if you use Azure, for example, you're going to still use a cloud bucket. And the reason I'm emphasizing this is because this is one of the key architectural decisions that we've made that enables a lot of the experience innovation, right? Because once you have this like well-defined API, now you're able to really decouple the concerns. You're going to be able to basically say, well, when I'm running in a simulator, what is a bucket? In order to implement this contract, it's basically putting a file, getting a file, listing a file, right? Like there's a bunch of operations that I need to implement. It's basically just putting files in the file system. Or a queue is basically just an array in the memory, or a counter is basically an integer, right, in memory. But once you go and you deploy those things into the cloud, then they become the distributed versions of those resources. So yeah, Mark was saying bucket happens to be a great name for object stores. And so we adopted this name. We actually had lots of debates about this because obviously it's interesting. Go ahead. I was interrupting you.
No, and I follow. So talking in AWS, I can say this most likely will be an S3 bucket, but could it be something else depending on how it's structured?
Yeah. So first of all, if you compile this down to TF Azure, it's going to be an Azure object store. Okay. And you can actually use what we call Wing plugins, which is the compiler hooks, to decide exactly what would be the backing implementation of a cloud bucket. So for example, someone could build a Dropbox backend for cloud bucket. And then when you put a file, it'll put it in Dropbox. And
interesting. Okay. So that's really clever. So, and I guess what I'm saying, or what I'm driving at, or kind of in my head, I'm thinking is, while you're opinionated, you're also leaving a lot of opinion to the customer, to the user. This is a kind of a blend of because we've seen you have to know all about infrastructure. We'll do all of it. There's two sides to the pendulum, right? Yeah. So you seem to be landing a little more in the middle here, and it's an interesting idea. I like it, but I have control. So if I use this pattern, it's going to throw a bucket every time in AWS, unless I declare, hey, no, I want to use a Dropbox bucket. I want it to save, on my kids, VTech, whatever. If I can write the plugin, it happens. That's
Or
really
you
interesting.
Or by the way, you could write a plugin that makes sure that all your buckets are encrypted, or all your buckets don't have public access, or all your buckets have, I don't know, cross-account policies attached to them. Or I think this is it's a good point, right? Like I feel like what we're trying to do is we're not trying to say we're going to take care of all of your DevOps needs from now until forever, right? Like I'm coming from the field, right? Like I've seen real world cloud applications. They get very hairy on the infrastructure side. And I feel that without that control, you can only go so far, right? In terms of like the amount, the ability, your ability to support use cases, right? Like, so what we're trying to do is we're basically trying to decouple what we sometimes think about as functional concerns and non-functional concerns.
Okay.
And give teams the ability to fully control everything below the abstraction, right? So when I write those plugins, and we have some blog posts about it, which is Hassan wrote, which is amazing. It's like when I write those plugins, I'm actually working below the abstraction. So I'm with S3 buckets. I'm not with cloud buckets anymore. And so I can customize exactly how I want my S3 buckets to work, or I want my Lambda functions to be inside of VPC, or I want replication or whatever, right? Like any cloud-specific provider-specific thing. That doesn't mean that from a simulated, in the simulator, I care about that, right? Like as a simulator, I don't care if the bucket is encrypted.
Right. It's just storage. It's a bucket. So we had it, and someone's already answered. Ayal already answered it. I'm sure I slotted that name. Ayal. I apologize up front for names. Eric Hammond actually threw this out there. Could a bucket be implemented as an AWS Dynamo table? And the answer is you can supply any implementation that will adhere to the cloud.bucket contract. So, really interesting idea here.
Yeah. By the way, from a programming language perspective, one of the things, and we still don't have that in the language, but one of the things that we have in the stack, in the programming stack, is that in a sense, when you're instantiating Cloud Bucket, you're instantiating an abstract class. And that's kind of like a head-bending idea, right? Like, because as a developer, every object-oriented programming language that I've ever used doesn't allow you to instantiate abstract classes, right? An abstract class is like abstract. So the compiler would tell you, I don't know what you want from me. Wing has this dependency injection system built into the language. Because what is a dependency injection system? Is like, give me something that implements this interface, and later on, we're going to bind that specific implementation. And so Wing has that built into the language and the compiler, which I think is a really interesting and powerful tool, especially for things like that. You know, when you want to create multi-cloud applications and portable cloud applications, and again, being able to decouple some of the mechanical constraints from the functional constraints.
Yeah. Now, I do want to, I'm just going to brag for a minute here. I do want you to take note of my poker face. So a lot of the things you said, I just, oh, obviously. Now you explained it. Now I understand it. But when you first said it, I was like, I have no clue what you're talking about. I don't know what's wrong with an abstract class. Let's do it. You know, so that shows you. So good explanation. I appreciate you clearing that up.
Thank you.
And Matt Bonnick is saying, man, that console is hot. So he's very eloquent.
Wait. Let's continue. Should we continue with the Shai? Is there
let's
anything
do it.
that you wanted to add at this point?
No. I just wanted to say that we have so much more to show.
Right. He's like, show the fucking demo.
We're good.
Okay, so let's do it.
Let's do it.
Obviously, there's no demo nowadays since November without OpenAI and ChatGPT and stuff like that. Right? So we have to do stuff.
Yeah.
And so let's build a new Wing resource. And Wing resources are, if you're coming from the CDK, are basically constructs. And we've been debating a lot about the name, and maybe we're going to change it somehow, but you can think of them as Wing's classes. And the reason they're not regular classes is because of this multi-phase interface that they have, right? Like as opposed to regular classes, they have a single interface. Wing classes, Wing resources have two interfaces. They have the pre-flight interface and the in-flight interface. We saw this example where the bucket has a bunch of methods here in the in-flight context, those methods don't exist here, right? This is actually a different API.
Okay.
And so that's, by the way, one of the reasons we had to build a new language, because no existing language allows you to do stuff like that.
So that's contextual to the object you've created, if you instantiated, and to where it is in the. So I'm dumbing it down for Eric right now, but and to where it is in the code, right? So it's contextually. I'm inside of a function, right? So I should only be able to do what a function can do to that constructor resource.
Exactly.
Got it.
Exactly. And I feel like that's that's an interesting innovation from a language perspective, because I don't know good programming existing programming or popular programming languages that allow me to do this naturally.
Well, and I said this before we started. In all kidding aside, I'm not the strongest developer in the world. I'm an architect. I'm good at architecting these distributed things, but development is something that I don't do as well. And so when I'm relying on context like that, and I get all this stuff that doesn't apply, it's very confusing. So I love the filtering limitation, however you want to say it.
Exactly. And I think that's another point, right? Like, we're trying to build Wing to democratize the cloud, right? Like, we're not trying to build Wing as a niche, research project, right? Like, we're trying to make sure that it's familiar and easy to learn and understand. You see that I didn't even have to explain anything about the syntax almost, right? It's very intuitive because you've seen languages that look like that. So there are some quirks and some novelties, but generally speaking, we're trying to design it so that it's approachable and easy to learn, right? That's not our goal. Our goal is to make it easy to learn about the cloud and what we think of cloud-oriented programming, right? Because, like, when you think about solving problems differently, when you have the cloud as in your toolbox, right? So I feel like that's the reason we're doing this. Okay, so I'm going to create this thing called assistant, and it'll have a persona. So in it is kind of like our constructor. And now I'm going to want to interact with OpenAI's API, and that's something that we don't have natively in Wing. And so what I'm going to show you is how to call out to JavaScript, because, as I said, Wing compiles to JavaScript, which means that we can interop with the JavaScript ecosystem, similarly to how C++ interrupts with C and Rust interrupts with C, and JVM languages interop with the JVM, right? And so we're basically interrupting with Node and with JavaScript. And so what I'm going to do, I'm going to copy this OpenAI JS file into my directory. By the way, you see my project is basically a directory. There's no like init, templates, progen, setups. It's all batteries included. Just give me a file and that's it. I'm going to take care of everything else. You see, I didn't even have to run a compiler in the background or watch in the background. This thing is constantly watching and compiling for me. It's all transparent, right? Like, I didn't even have to do anything. And again, I think like we've been kind of neglecting some of those tool gluing craft that we've gotten ourselves into as an industry. And, I've built Progen, which is in a sense a tool that is designed for gluing tools, right? Like that's what.
Yeah.
And
duct tape and baling wire, man. Yeah. So what's in the OpenAI?
Go ahead. Let's do that. Yeah. So I told you, it's dangerous to tell me that there's.
Well, we're good. I'll keep you going.
Okay, so let's see what's going on here. Nothing very interesting. It's basically calling out the OpenAI API. It's exposing it through a function called create completion. And so what I'm going to do here is I'm going to basically define an extern that says, okay, OpenAI.js gives me this function called create completion. It takes in a prompt and it returns a JSON. That's the signature of my external function. Now, the reason I needed this is because I'm bringing this function into my Wing my Wing code base, and I want to make sure that it's strongly typed, that I know exactly how it's called. It's not just JavaScript garbage in, garbage out type thing. And so you can see, and the other thing that you can see here is this type called JSON, which is a primitive type in Wing. Wing actually, in the future, is actually going to be like this. And that's another interesting thing about the fact that Wing is cloud-oriented language. Of course, it needs its primitive type as JSON, right? Like
Sure.
I can't think of any cloud application that I've ever written that didn't do a lot of JSON.
Right. Yeah.
And the other interesting thing about JSON, which we'll see in this, we'll see it in a second. So, okay, so now I have this extern thing. This is kind of like this private thing that I have. And I'm going to add a method called ask, right? Because it's an assistant. And then it has a question. And what it's going to do here, it's going to call create completion. And then we're going to craft this prompt here. You are a persona. I will ask you. I will ask you a question, and you will respond. Here is my question. I don't know, just making that up. I should go learn prompt engineering. See, our language server just crashed, so I'm going to reload this thing. This said, and okay, so now I can pass in the prompt here, and I can get the result. And now let's see what it tells me. It says cannot call into pre-flight phase from while in flight. And that's because I didn't mark this as an in-flight function, right? Like I need to actually tell Wing, hey, this thing can be called from the cloud, right? Like it's not a pre-flight thing, it's an in-flight thing. So some way to think about it is kind of like async programming, right? Like you can't call an async function from a synchronous context. You need to wait, you need a promise. And so we sometimes we think of in-flights as a sort of async functions that are running in the cloud in a way.
Okay.
So now I've called that thing, and the result I get is a JSON. And I want to extract the text from the result. And I have a little cheat sheet here that this is what I'm looking for. And in the future, this is going to look like this, like JavaScript basically. But right now, I actually need to do a little bit of function calls here. That's not going to stay like this. Okay, so now this is the text. And as you see, this text is still JSON. It's not a string, because all we know about this thing that was returned from create completion is that it's a JSON object. And so that's an interesting thing and a bit of a difference between TypeScript and JavaScript and Wing, which I think is really interesting, because JavaScript and TypeScript, and one of the reasons JavaScript is very popular in the cloud is because of its JSON connection, right? Like because it's very natural for you to interact with JSON. Absolutely. However, it's not very safe. It's not very safe, right? And even if you use TypeScript and you say, okay, this is the interface that I expect, these are the types, what you're doing, you're basically slapping this view on your dynamic object, right? And so if that object is not really adhering to that view, you'd know that only in runtime. You never know that you'd know too late sometimes. This thing is already infiltrated into your code. And so what we're doing with Wing is we have this basically bridging between the untyped world of JSON and the strongly typed world of Wing, which means that if I need to take a JSON value, and I know that this is supposed to be a string, and get a string from it, then what I need to do is I basically do str, which is Wing string type, from JSON text. And this is basically, if I look at this, now it's a strongly typed string, and it's also validated to be a string. So if this is going to be a number, I'm going to get an error. And so from a developer's perspective, I know that I'm in a safe space. I'm never going to get a string. I'm never going to get something that's not a string in this case. And now for strings and numbers, maybe that's not super interesting, but think about structs. Wing has this of shapes and structs. And so you can define these structs, and these structs become JSON schemas, inherently. And when you do struct.fromJSON, it'll process the JSON and it'll validate the schema. You can disable it, of course, but it'll validate the schema. And you can also export the JSON schema out if you need, because I want to make sure that when you actually use this struct, it's a strongly typed object and it adheres to that interface. And so again, this is an example of like what is cloud-oriented programming? Like is this ability to interact with the cloud in a natural way. Okay, I've been talking too much, of course.
You're good.
Okay, so now I've returned the stream. Shall we try this and see if it works?
See if it works. If I did this, it wouldn't work the first time. I would have already tried it 30 times with it broken until I got it working.
Okay, so I need to create an instance of my assistant. What do you want? Should we do a comedian?
Yeah.
There you
go. And the comedian is, how does it say? You are a comedian. I will give you, my prompt will be a topic, and you should return a response. You should write a one-liner joke about this prompt. Something like this. That's its persona.
Okay.
Call it prompt. And now I'm going to use this comedian in my function. Shai, did I forget anything?
You probably want to put something around the prompt, around the question.
Oh, okay.
We saw that OpenAI's API.
Question you respond here is like, I'm kind of surrounded by, and you will respond without the. This is a new type of programming, I have to say. I'm like still figuring that out. Okay, and now this is gonna. You mean like this, right?
Yep.
Okay.
That's the AI syntax?
That's what you know. This is a new thing of prompt engineering. Is like this.
Yes. Okay. Gotcha. Gotcha.
Okay. So you see, I created an assistant here. I'm gonna give it a name, comedian. And you see that this is this has been loading. I have like my little comedian here. Nobody's talking to it at this point. And now I'm gonna call it, and I'm gonna ask it to. I'm gonna ask it to tell a joke about
serverless.
No, about serverless. Okay, let's do it. Oh, sorry. So here's the blue screen of death, which is how our console is showing compiler errors, which is
Microsoft workers right here.
Okay, joke, and I'm just gonna print it. You can see that it's just loading automatically, and you see that now I don't have a connection to the bucket, but I do have a connection to the comedian. Oh, I need to install OpenAI.
While I'm installing OpenAI, I'll touch a point. I think the only point that you didn't touch so far is the async programming. So we mentioned that the in-flights are kind of like they're async functions that are running on the cloud at a different time on different machines. But you can see that when we access them, when we access other async functions, we don't need to use the async or await keywords. And that's something that we've added in Wing that I think really, again, like a natural way to interact with the cloud. Like in the cloud, almost everything is asynchronous. And there is no reason that if you forget some await somewhere, and I think it's happened to everyone that's ever used async await, and then there are like these horrible bugs that are very hard to find. So with Wing, it's async by default, and you actually, if you don't want to await a call, then you actually need to defer, and then you can await it. So,
okay. All right. So it's kind of the opposite. By default, you're asynchronous, and you need to declare synchronous. Okay.
Yep. Okay. Damn it. I'll just restart it.
Usually works.
Usually, I actually had some.
This is called live programming, folks.
Exactly. No, this is happened to me a million times. Okay, let's see. I'm always serverless during a thunderstorm. Oh, nice. It's all dad jokes, by the way.
Yeah, no, that's great.
It's
Okay.
GPT-3, not 4.
Okay,
All right.
moving on.
Okay,
I think
all right.
this
I have
is-
a few questions about that, but yeah,
Sure.
let's move on for
Sure.
a second. I want to come back to that. I'm watching for questions in here. We're getting some people are getting pretty excited about this. David Boyne, oh yeah, I can see it. So I don't know what he's talking about, but I'm assuming he's getting some excitement from what you're showing here. So
Okay, so you said you just learned Hebrew. You really didn't learn Hebrew, so let's.
I took Hebrew. Yeah, there's a big
do
vast
something
difference
with that.
between.
So I'd say now I want to start composing things and reusing things, right? But because I created this cool assistant thing, so now I can create a translator, right? So do a new assistant inside, which we'll call, and you are an English to language translator.
So that assistant declared a new assistant.
Yeah, this is
So
basically a
shorthand.
member, right? A field
Okay.
of this resource.
Okay, gotcha. All right.
And that's it. I guess this is just please respond with the translation of the prompt to language. Okay, and then I'm going to create an in-flight API for it called translate.
It's very important to be polite with it, and that's completely.
And it's going to go to
I
the
heard what you were saying, Shai.
No, I just said it's very important to be polite with it and use.
Oh yeah, there you go. Yeah.
Okay,
cool. So I have this translate method, and let's add translation. Which language?
It's Hebrew. Let's try
Hebrew.
Yeah.
I'm just going to create a Hebrew.
I'll try first, and then we'll see what it. No,
okay, let's see. A race between you and.
Yeah, no. That would be. It's not tortoise and the hare. It's the tortoise never left the barn.
Okay, so I'm going to translate to Hebrew. Hebrew.translate joke. Hebrew. Okay, cool. So I've got this little comedian. This function, and it talks to the comedian, and it has also a translator. Now it's like another layer of abstraction, right? And I can give it a name. I can call it Hebrew. So now I have like this Hebrew translator, and let's see if it's working. By the way, sometimes ChatGPT just doesn't respond, so I'm gonna just hit it again. There we go. To get to the function on the other side, and the Hebrew is like, למה עשה פיתוחן ללא שרת חצייה לכיוון האחר כדי להגיע לפונקציה בצד השני?
That's how I read it. I got it.
That's how I read it, exactly.
That's a big fat lie. Yeah. That's awesome. All right, so here's my questions. Okay, I got it now. We've abstracted this all away. We brought this in, but I want to go in. So let's go back to your code for a second. In looking at this, so I see that we created the cloud function, right? On AWS, that's going to create an AWS Lambda function, right? So we've got that. But line 28, you're doing another in-flight. Is that another Lambda function that'll be generated?
No.
Okay.
No, I think, and again, it's a good point, by the way. Distinguish between the resource, right? Okay. This resource cloud function, and this closure or this piece of code that's denoted with the in-flight modifier, right? This piece of code is not a resource in the cloud. It's basically just a piece of code that you can hand over to a resource called cloud function. You could, in the future, you'd be able to hand it over to a resource called cloud service. And so it'll run on Fargate, right? And that resource represents a Lambda function, not the in-flight closure, right? Like the in-flight, basically, it's kind of like saying async, right? Does that make sense?
I think so, but I'm curious about. Can you scroll back up on the code here?
Sure,
I'm curious, and I'm a great person for this because I'm dumb as a brick, right? So when we think about, you have this resource translator, right? You're creating that. Where is that call being made from, or where is that happening?
So it's happening inside this Lambda function, right?
The same function. Got it.
Yeah.
Okay.
And it's just it just calls it out. It's kind of like a client, right? Like it's kind of like now it's
gotcha. All right.
and Wing would bundle the JavaScript code and all the dependencies and the OpenAI dependency and everything into this thing and create a zip file that will contain it all. And you can just call this in-flight code naturally. So there's a lot of stuff going on behind the scenes here, right? And we didn't even talk about permissions, right? Like if I have a bucket here and I'm putting a file in the bucket, Wing sees that this is a put operation. And so the IAM policy of the Lambda function will have the least privileged permission based on the code, right? I don't have to specify any grants or any specific IAM permissions, just like completely implicit.
All right.
Yeah, I mean, we can easily do more, right? I don't know if if we have time for that or not.
I'm giving you your 10-minute warning, so there you go. Shai, what were you going to say? You were going to say something?
No, I just wanted to say that it goes. It's worth to see the conclusion.
Okay.
Never
all right, let's do it.
Yeah. I mean, well, let's make it a little bit more complex, right? Let's say that now, instead of translating, in place in the same Lambda function you were asking, right? Let's publish these jokes into a topic, and then we can have translators subscribe to the topic and just translate, like asynchronously. That's a classic architecture, right?
Sure, yeah.
So I'll create a new joke topic, new jokes. And here, I'm just going to do publish my joke. And now my translator, what I'm going to do is I'm going to pass in the new joke topic to the translator. I'm going to add topic here. Right. And and here, basically, it's going to do topic dot on message, right? Like every time a message is being sent to the topic, then what we want to do, this is going to be the joke. And we're going to basically there's a bit of a bug here. So bear with me. Translate joke. Result.
Joke just kills me.
I
don't know if Revital, I'm probably saying that wrong too. She's laughing at me or the Hebrew translation, but she was laughing at us. So just
yeah. Okay, you reload. And so this is going to translate. Let's see. Okay, so here we go. So we've got, see this architecture being constantly being updated, obviously. And I'm always trying to think, what was my life before this? Truly, like I would go and I would deploy it. And again, I've built some of those tools, of course, and I love them. And I think that, the power you get from using the cloud is amazing. When I was in the CDK, we've done this analysis of, how much people use the cloud versus people that don't use the CDK. And it's staggering to see how when teams are able to leverage the cloud and lean on the cloud, and I don't have to tell you that, they become so much more productive because they're able to focus on their applications instead of focusing on, scaling and monitoring and operations. And I think this is just giving the developers that value, because I feel like developers have been kind of paying some of that cost, right, of using the cloud, and became so anyway, I constantly have to think about that. So we have this topic here, and by the way, something here, there's a bug here in how the scoping works, but so it's a little bit of a mess. But you can see that my Hebrew thing, this is the onMessage Lambda function that basically is generated for me once I subscribe to the topic. So when I did on message, it created a Lambda function, and it executed the code inside this Lambda function. And so this is the little topic. You see the icon here. And so let's see if this is actually working. Damn. actually worked.
It did.
And the other thing that I can do is I can add another language, right? So let's do that. Now I don't need this, by the way.
All right. So while you're typing that out, my question is, in this architecture, then did the same Lambda function send the request and react to the topic?
No.
Okay.
No.
So the on message, while Elad is typing, I can answer. So the on message, as Elad said, basically created another Lambda function.
Okay. That's okay. Got it. Okay. All right. So they're separated concerns. I like that. Okay.
Yeah, they're decoupled, right? Like the topic
Okay.
basically created this distributed systems
Right.
decoupling.
Well, and I was thinking, well, to write the filter, then you a bunch of if-thens. What am I coming in for? So now we've got two Lambda functions that are generated. Got it. Okay.
Right. And I can see them here, right? Like they're
Okay, yeah.
visible here. Okay, cool. So you see now I have my French and my Hebrew, and I'm gonna run this again.
Joke
Hebrew.
generated.
No French. I'll try it again. We've had some hiccups when we were trying this.
Or we can try.
You're not even appreciating the jokes, guys. Took my server to get serviced, and the mechanic told me it was serverless.
We can maybe try Spanish because it works with
That sounds great, but the Hebrew is here. Oh, there we go. Here's the French.
There
In
it
French.
is.
Okay. And so again, I think what you can see here is this multi-layered model, right, of your application, and obviously we're going to work on zooming in and zooming out, because you know that true real-world cloud applications have hundreds of these resources.
Yeah.
And the fact that we have a mental model as developers that decomposes the problem, right, into smaller pieces and then composes them back together is something that we want to carry over, right, from your code into your interaction with your application, which is something that I feel is really missing today in the operational experience of the cloud. Yeah. And so this is where this is heading, right, is basically being able to interact with your real application using the same view.
Let's put the jokes in a bucket.
Should we? I don't think it's that important. But we can do that too.
Just to show the counter. I really like the counter.
You really like the counter. Okay.
Excuses to use the counter. So we have
now every joke needs to be stored in the bucket. Okay, that's the next phase. By the way, you've seen I've added this store here. I get this compilation error, which is great. I'm going to create a bucket, a joke store, and I'm going to pass it over here and over here. And now, basically, what I want to do here is I want to go store.put, and I need to put it in some key, right? Sure. And so I'm going to use a counter. Like we have this thing, we have a cloud counter, which is it's actually an interesting resource because it doesn't exist. There's no counter in AWS. The way you do it in AWS is use DynamoDB atomic counters, and in Azure there's something. And but from a developer's perspective, it actually makes sense to have a counter, right? Something that can count things, and you know that it's not a simple thing to do in distributed systems because there's obviously it's a distributed access to this thing. And so in Wing, we basically have this thing called counter that abstracts that away. And when you compile it to AWS, you get a DynamoDB atomic counter behind the scenes. And so this is going to be the way we create IDs for my thing. And so the key is going to be the language /ID.text. So this is going to be the key, and this is going to be the result. Simple. And you see this is getting more and more complicated. Now that I have my little joke store here, and let's see if it works. And if it works, we're gonna just stop, right?
Yeah, we'll call it. Call it a win, and yeah, we're about a minute from time here, so that works.
Okay, the Hebrew, the French, joke store, Hebrew, and French, and there's some. Oh, I forgot to increment the counter. I can't. I'm sorry. new
Okay,
ID,
you gotta fix it.
ID dot increment. So that means that every time I'm going to get a new ID, and that's not going to work, and it's all going to crash now. And I should have done.
We're not going to get our satisfaction.
Wait a minute, we'll see. Well, I can't tell you, and if you've watched this, you heard me say this repeatedly. I can't tell you how many times we follow up a show with a tweet that says, "Here's what was wrong. We fixed it."
Right, of course.
So that's very
risk,
common. That's live coding, man, and that's why I love the show. I like doing it. All right, there's the joke.
Serverless, that's the dream where I don't have to wait tables to pay bills. Oh, serverless. I actually think the serverless jokes are pretty good. We were trying programming jokes earlier, and they were very bad, actually. Okay, we've got the Hebrew, we've got the
French, and there's
Hebrew 0. Yeah, so we have the counter and everything, and
that's cool. Very well. All right, so we're gonna have to wrap it here. But so real quick, what's coming? So what's not here that's coming? If you want to talk, if you want to keep that under wraps, that's okay.
Basically what's coming is this is going to be stable. This is going to be fast. This is going to be ready for people to use and build real things with, right? This is our focus right now. We've worked on actually building a lot of that surface area, understanding exactly what goes in and out. And obviously it's a moving target. It's going to continuously change and evolve. We're going to have some more resources like the API resource, which is really cool and interesting, right? Like you can have endpoints and websites and secrets, and all of it is public, and the roadmap is public, and we're encouraging everyone to tell us what they think and what's important and what's less important, and if they like the syntax or they hate it, or we're really sharing almost everything we're doing. We're putting up meetings on YouTube, and we have this stupid Twitch thing that we're doing every couple of weeks, and talk about what's new with the project. We've got about
I told you before, you don't sell them well. I'm just telling you right now, it's a stupid thing, not worth watching. But if you got nothing better to do, that's not true. It's always interesting. Watching Elad code is cool. So.
And we're going to have a playground soon, so you could, without installing anything on your machine, you can just play with the Wing code and have the console view to the side, and just create cloud applications and play with it and learn the language.
All right, sounds good. Hey, Elad, Shai, I really appreciate you all joining me on my little show here, this stupid little show. No, I'm just kidding. It's not a stupid little show. It's a great show. I love doing it. And so thank you very much for joining me. I appreciate, Shai, you had the same background. I feel like you made an effort. I do appreciate that. Elad had it too. I think he turned it off. So, but next week I'll be coming back. What's that?
I want it to be special.
You are. Next week we'll be coming back. I'll actually be digging into some SAM Accelerate, where we are doing a lot of the instant test in the cloud kind of stuff. So that'll be kind of fun. I'll be showing SAM Accelerate's been around for about a year or more now, but I think people struggle not struggle, but they haven't kept up with a lot of the new things. We've brought a lot of new things to it. So I'll be showing that next week, kind of a deep dive into SAM Accelerate. And again, I just want to thank you all. I know it's probably like 3 a.m. in Israel. So it probably isn't, but I always say that, but it's 8 p.m., which is late for Elad. He's pretty old. So, he needs to sleep. So, Shai, Elad, thank you very much. And with that, I'm going to sign us off. Thanks for watching. And we'll see you later. This is